So in this lesson, we're going to talk about solving trigonometric equations on a circle. So when we're solving an equation, we're looking for the variable. The variable here is theta, and that means we're trying to find out what the angle is. Now what we're going to discover is there's almost always more than one answer. So we have to be a little careful figuring out what's going on. So in this problem here, it says solve sine theta equals 1/2, and theta is between 0 and 360. So I'm going to draw two circles here. I know that seems a little unusual, but you will see why in a second. I'm going to draw two circles. I'm going to draw them big because I need lots of space to fit things in. And then I'm going to realize when it says sine theta equals 1/2, it's really saying that's y over r, because that's what sine theta means. Now, r is always a positive number, so in this case it's saying y also has to be a positive number, so we get the positive 1/2. So where can I put an angle so that the y is positive? Well, anywhere on the top half circle would work. So I could draw it into the first quadrant, or I could draw it into the second quadrant. Both of them would be okay, so I'm going to draw both of those. I'm going to draw an angle that goes like that, and I'm going to draw an angle that goes like that. Okay, so now I'm going to fill in this triangle. I'm going to make the reference triangle like that, and I'm going to do the exact same thing on the other one. And I'm going to start labeling the sides that we were told. The y over r are the 1 and 2. So I'm going to label the 1 over here on the y, and the radius is 2. And I start thinking, what triangle do I know that has 1 and 2 in it? Ooh, 1, 2, root 3. So I now know what the reference angle needs to be. This was a degrees problem, so the reference angle there opposite the 1, that must be the 30 degrees. Now I go to the other diagram and I get the exact same thing. The y over r is 1 over 2, so the y must be 1 and the r must be 2. And of course I recognize this is a 1, 2 square root 3, but this is actually a negative square root 3 because of the x-coordinate is negative. However, the reference angle is still 30 degrees because it is opposite of the 1. Now the question wasn't to find reference angles, the question is to solve for the angle, and generally speaking the angle is a standard position angle. So what I need to do is work out what standard position angle made this picture. Well, that one's kind of obvious. If I just do my 30-degree angle, I would create that picture, and 30 degrees is between 0 and 360, so there's my first answer. Theta equals 30 degrees is one answer. Now to get this one, on the other hand, I need to go around like this. That's still a positive angle. I wanted something between 0 and 360. That's a positive angle, and it's less than a circle. So this is the one I want. Well, this was almost 180, but it was missing that reference angle of 30. So that angle there must have been 150. That's 180 minus 30. So here theta is going to be equal to 150. So there are two solutions, theta equals 30 and theta equals 150. How did I figure it out? Well, first of all, I realized that sine theta is 1/2, means y over r is 1/2. And since r is positive, that forces y to be positive, and then there's two places where I can do that. So I drew my two circles, and I figured out, well, the way to get y over r to be positive is to go into the first quadrant or to go into the second quadrant. And then I drew my reference triangle. I put in the sides of the triangle that I knew based on the y over r. And then I said, hey, I recognize that as a 30, 60, 90. I labeled the third side. That's not necessary, but I did it anyway. And I worked out what the reference angle needed to be. Once I have the reference angles in both triangles, and it'll be the same reference angle for both triangles, so that's convenient. Then I had to work out, well, the reference angle wasn't the question. The question is, what's the standard position angle that makes that happen? So I drew the standard position angle given my restrictions over here, and I worked out what two angles in this case solved the problem. And so the answers in this case for solving the equation were the angles that I needed to make it work. All right, so here we go. Solve cosine theta equals -2 over 2, 0 less than equals theta less than equal to 2 pi. Okay, so once again, I expect two answers, so I'm going to draw two circles. And again, almost always there will be two circles. There are exceptions, and we will see one exception later on in the examples later. Okay, so this cosine theta equals -2 over 2, when I have that, when it says cosine theta equals -2 over 2, what I'm really saying is that x over r is negative root 2 over 2. Well, again, r has to be positive, so the negative must come from the x. So for x to be negative, I need to be going into the left side. So either I go into the second quadrant or I go into the third quadrant. So let's draw those angles. So there's the angle that goes into the second quadrant. There's the angle that goes into the third quadrant. Now I'm going to complete those triangles, those reference triangles like this, always to the x-axis, don't forget, and like that. Now we know that x over r is negative root 2 over 2, so let's label the x the negative root 2 and the r the 2. So in this case, negative root 2 for x and 2 for r. In this case, negative root 2 for x and 2 for r. And then I say, wait a minute, I recognize these sides. These are the 45, 45, 90 degree sides. So there's another root 2 on there and also over here. But if I think about this picture here, I recognize that actually is not a root 2, but a negative root 2 because the y-coordinate there is negative. This one is a positive root 2 because we're going up. So again, we recognize these were 45, 45, 90 triangles, but this is a radians problem, so I don't want 45 degrees. Instead, I want pi over 4. So the reference angle there has to be pi over 4, or that one again is pi over 4. Okay, so again, the question was to solve for theta, not to find the reference angle. Theta is the standard position angle that I want. So for this first diagram, again, between 0 and 2 pi, those are positive angles less than a circle. So I need to go like this. So what angle makes that happen? Well, we almost reached pi, but we were missing pi over 4. So it's a little bit less than pi by pi over 4. So pi minus pi over 4. Well, that's 4 pi over 4 minus pi over 4, so that's 3 pi over 4. Now for this diagram, again, I have to go up and counterclockwise to get a positive angle, and I need to then stop there. Well, this one was a little bit more than pi, a little bit more than a semicircle. It was pi plus pi over 4. Well, pi again is going to be 4 pi over 4. When I do 4 pi over 4 plus pi over 4, I get theta equals 5 pi over 4. And so those are my solutions. Theta equals 3 pi over 4 or theta equals 5 pi over 4. Okay, let's solve tangent theta equals negative root 3 over 3 for 0 less than or equal to theta less than or equal to 2 pi. Well, first of all, I'm going to draw my two circles, anticipating two solutions. So what we are saying now is that tangent theta equals negative root 3 over 3. Now I want to point out to you that I don't recognize these sides for one of my memorized triangles. So I don't really like the way that was written. I'm going to mess around with it a little bit. So usually we'd rationalize the denominator, but I'm going to try to rationalize the numerator just to see what happens. So I'm going to multiply top and bottom by root 3. And so I'm going to end up with negative 3 over 3 root 3. And the 3's will cancel. It says negative 1 over root 3. And now those sides I recognize from the 30, 60, 90. So what we are really saying here is that negative 1 over root 3 is the y over x, because that's what tangent theta means. Now here's the thing. There's no restriction on which of those has to be negative. So negative 1 over root 3 is only one of those possibilities. It could also be 1 over negative root 3 for y over x. It's only r that is forced to be positive. X and y could both be negative. So in order to get negative 1 over root 3, either I have negative 1 over root 3 for the y over x, or I have 1 over negative root 3 for the y over x. So the negative 1 over root 3 for the y over x, that the y is negative, the x is positive, that's going to put me over here. For the 1 over negative root 3 for the y to be positive and the x to be negative, that's going to put me over there. Now I'm going to complete my reference triangle. And I'm going to do it on the other one as well, always to the x-axis, don't forget. And now for the first diagram, which was the negative 1 over root 3, the y is negative 1 and the x is root 3. So that's negative 1, and that's root 3. And again, I recognize this is a 30, 60, 90, so 2 is the third side. For the other one, y is 1 and x is negative root 3, so that's 1, and that's negative root 3. And again, I recognize that the third side has to be 2. Now I look opposite the reference angle, And you notice that opposite the reference angle is the smallest side. So it needs to be the 30-degree angle. This is a radians problem, though, so I can't label it 30 degrees. But 30 degrees is exactly 1/6 of 180, so pi over 6 is the reference angle. And of course, the reference angle on the other one is also going to be pi over 6 for the exact same reasons. Once again, I wasn't looking for reference angle. I was looking for angles in standard position. So I got to, and in between, in this case, 0 to 2 pi. So I got to go around to get there. So the first possibility is to go around like this with the arrow, the standard position angle. Well, that is almost 2 pi, just missing pi over 6. So I need to take 2 pi and then minus pi over 6. Well, 2 pi is really 12 pi over 6. So 12 pi over 6 minus pi over 6, so it's going to be 11 pi over 6. So theta is going to be 11 pi over 6 from this first diagram. Now for the second diagram, again, I need a positive angle between 0 and 2 pi, so that one right there. So now this one is almost reaching pi, but it misses the pi over 6. So it's pi minus pi over 6. Well, pi is really 6 pi over 6, so 6 pi over 6 minus pi over 6. That's the common denominator method. So theta here is going to be 5 pi over 6. And so those are the two answers, 11 pi over 6 and 5 pi over 6 were the angles that we didn't know. Okay, let's solve cosine theta equals -1 between 0 and 4 pi. Okay, that's going to mean 2 circles worth of angles. Cosine theta equals -1. Now, before I draw my circles, I'm going to notice that cosine theta equals -1 is really x over r. Well, that just means that x and r are the same, except x is -r. Now, if the length of x is the same as the radius length, of course, in this case, it's a negative number, you cannot go into one of the quadrants because that would create a right triangle and the radius would be the hypotenuse, which is definitely longer than x. So this is not going to create a triangle. This is saying the x coordinate is -r. There's only one place to do that. Now, just because in this scenario we only got one triangle, one circle, doesn't mean always you get one circle, but in this case we do only get one circle. The only way to get x equals -r is to go right there. That point there is -r, 0. So I really only have to get this angle to make it work. Don't have to worry about a triangle, don't have to worry about reference angles. I just need to get standard position angles that fit. So this standard position angle would do it. So theta equals pi. But the problem is I said I can go between 0 and 4 pi. So I could also go around once and then stop there because it's still less than 4 pi. Around once and then stop is another possibility. So in this case, that's 3 semicircles. So theta equals 3 pi is also okay. But if I kept going around now, I'd get past the 4 pi, and so that would be the end. So again, there was only one circle here because the x had to be exactly -r, and I can't make a triangle that gets one of the sides of one of the legs of the right triangle and the hypotenuse is the same length. So that's not okay. So I had to just find the coordinates instead. Okay, let's solve sine theta equals 0 between -pi less than equal to theta less than equal to pi. All right, so once again, I'm not going to draw the circle yet. We're going to think about this. When I say sine theta equals 0, what I'm really saying is y over r equals 0. Well, the only way for that to happen is for y to equal 0. Well, there's actually 2 places where I can do that. It does not involve triangles, but there's actually 2 locations where y could equal 0. And that is either on the positive x-axis or on the negative x-axis. That point there would be, for example, here would be r, 0. And that point would be -r, 0. Either way, the y-coordinate is 0. So now I need to work out angles in standard position between -pi and pi that make these 2 diagrams. Well, this one, I literally, if I go 0 radians, I've got it, right? So let's just go with theta equals 0. Now, if I tried to go around once, that would be 2 pi. It doesn't fit within the -pi to pi domain that I'm asked about. It'd be bigger than pi. It'd be 2 pi. If I tried to go negative, I'd have to go negative 2 pi. Again, it wouldn't fit between negative pi and positive pi. So I can't do any more from this diagram. This one, on the other hand, if I go, for example, like that, that's pi. Theta equals pi, which barely fits in the less than or equal to pi domain restriction. But I could also go a negative angle here, like that. That would be negative pi, negative a semicircle. And that also barely fits because of the equal to sign. So there's actually 3 different solutions, but there's only 2 diagrams. Again, because y over r had to be 0, had to work out where y is going to be 0. And of course, r is never 0. It's always a positive number, so it's not relevant in this problem. All right, let's solve tan theta equals 1 between 0 and 2 pi. Okay, I'm going to start with the tan theta equals 1 means that y over x equals 1. Well, I don't recognize a triangle that has y over x equals 1. But it doesn't mean that y and x are both 1. It means that y and x are equal to each other. So really what I'm saying is that y over x, if I think about the triangles that I've memorized, it could be root 2 over root 2. That would give me what I want. That would simplify to 1. But that's not the only thing, though, because these are both positive, but y and x could turn negative. If they were both negative, we'd still get 1 as our ratio. So it could also be y over x equals negative root 2 over negative root 2. So when it says tan theta equals 1, it actually is representing these 2 scenarios. So I do need to draw 2 circles here. So I'll draw 2 circles. So for y over x to equal root 2 over root 2, both positive, I would have to go into the first quadrant. So that would be over here. And then for y over x to equal negative root 2 over negative root 2, those are both negative. I'd have to go into the third quadrant. That would be over here. Then I make my reference triangles. And I put my root 2 and my root 2, for example, over here, root 2 and root 2. And I recognize, ooh, that's a root 2, 2. And for the other one, negative root 2 and negative root 2. And again, it's a negative root 2, 2. And then the reference angle there, well, that's a 45 degree. Well, I can't do 45 degrees. It's a radians problem. So it's pi over 4 radians. So the reference angle there is pi over 4. The reference angle there is also pi over 4. Now, I want to find angles between 0 and 2 pi. So I need positive angles that don't go past a circle. So this would be that one, standard position. Well, that's easy. That's just pi over 4. So theta equals pi over 4. Now the other one would be like that. Well, this is a little bit more than pi. It's pi plus pi over 4. Well, that's 4 pi over 4 plus pi over 4, which is going to be 5 pi over 4. So theta equals 5 pi over 4 is the other answer. Finally, let's solve 2 sine theta plus root 3 equals 0. Well, the first thing is I want to isolate the sine theta. So I'm going to subtract root 3 from both sides. So 2 sine theta equals negative root 3. And then I'm going to divide both sides by 2. So sine theta equals negative root 3 over 2. And now that I've isolated sine theta, I can start thinking about my circles. So right now I know that y over r is the negative root 3 over 2. And so there's actually 2 locations where I can make that happen. So I know that r has to be positive. So y is the one that has to be negative. So I would have to go into the third quadrant to make that happen, or into the fourth quadrant to make that happen. And now I can fill in my reference triangles first. So the y over r is negative root 3 over 2. So the y must be negative root 3. That's the negative root 3, and the r could be 2. Or this one could be negative root 3, and this could be 2. And I recognize this now as a 1, 2 square root 3, so the missing side is a 1. But of course, if I'm thinking carefully, that's actually a negative 1. And now I want to work out what the reference angle is. Well, that would be right there, or right there. Now this is, of course, the sides of a 30, 60, 90, but the reference angle is opposite the root 3, which would be the 60 degree angle, not the 30 degree angle, but 60 degrees is pi over 3. I want it in radians, so pi over 3 is the reference angle here. pi over 3 is the reference angle here. And now I need to work out the standard position angles that make each of these diagrams work. So that would be this one, and the other one would be this one. So for this first one, I recognize I went pi, and I added on my pi over 3. So theta equals, instead of pi, I'm going to call it 3 pi over 3, and then plus the pi over 3. So that's going to be 4 pi over 3. And then for this one, I recognize I almost finished 2 pi, but I was missing pi over 3, so I can think of it as theta equals 2 pi minus pi over 3. Well, instead of 2 pi, I'm going to call it 6 pi over 3. And then I'm subtracting the pi over 3. And so when I'm done with that, I end up with theta equals 5 pi over 3. And that is the end of the lesson.